Hello, everyone. We're happy to see all of you here today. Firstly, let us check the sound and picture quality. Please tell us in the comments box if you can hear us well and see the presentation. Thank you, Krishna. Okay, let's start. My name is Alina Zharikova, and I'm a business development manager of RULA Technologies. And today I will be moderating the webinar. Next to me is sitting Philip Stomschais, our today's speaker and software engineer. While we're still waiting for some people to join us, let me tell you a little bit about RULA Technologies. RULA is a leading-edge European manufacturer of test and measurement instruments. We implement customized solutions for automotive, aerospace, research, and other industries. RULA mainly manufactures vibration controllers and data acquisition systems, power amplifiers, and softwares. By the way, we manufacture 3 types of software: TestUp for vibration control, SignalUp for signal analysis, calibration software for calibration. And there is a special software for data logger RL-R17, software for the product which we are going to deeply introduce you today. During our today's webinar, we will present an updated version of RL-R17 and discuss its key technical features and improved functionality. Mainly, we will speak about key applications of vibration and shock recorder RL-R17, compare continuous and shock event recordings, as well as delve into temperature and recordings. Now, let me tell you a little bit about the technical sides of the webinar. First of all, on the top, you can see a red button, which you can push and see the question section, where you can tell us if anything is wrong with the sound or picture quality and ask questions. Or you can use a raise your hand tool to let us know that you have a question or want to pay our attention that we have some technical problems. And as always, we ask questions all through the presentation. I think everything is clear, and without further ado, we can give the floor to our today's speaker, Philip Stomschais. Philips, you're welcome.
Hello everyone. In this webinar, we are going to talk about our portable data recorder, RULA-17, its features, updates, and ways of usage. We will discuss the application ways, discuss work modes, talk a little bit about technical features and ways of post-processing the recorded data. So let's start with the technical description. Here in the slide, you can see the device. The device has an aluminum casing, has IP65 water and dust resistance. It has a 3-axis accelerometer and 2 additional sensors which can measure temperature and humidity. Also, the acquired data is stored in the non-volatile internal memory, and in that case, you can record all the data captured by the sensors. Let's talk about the key features of this device. As you see, it has IP65 resistance. It has adjustable sensitivity and sample rate. I'll show you that in the settings. Also, you can change the sampling period for temperature and humidity sensors. You can set it from 1 minute up to 1 hour, and of course fully charged device with some kind of settings which will help you to decrease the power, can work up to 1 month and record the data during the transplantation, for example. Here you see the table with main parameters. This device has 2 modes for accelerometers. It can have a range from minus to up to plus 15 G, and it can measure up to 190 G. Here you see the accelerometer accuracy and the temperature sensor accuracy. It has a frequency range from 0.1 Hz up to 800 Hz. It can measure temperature from -40 up to +60 degrees Celsius. And here you see its sample rate and its maximum battery life. Also, let's talk about its ways of usage. I can say that there are three main ways for the portable data recorder. The main sphere of the device is transportation and shipping spheres. For example, you have a case or a shipment container with some expensive equipment which will be transported somewhere. So you place RL-R17 into the container, box or case, start the recording, and after the shipment you can check all the shocks, impacts, humidity and temperature for the whole, I can say, trip. And after the analysis you can make results about the shipment quality. Also, another way is to capture the direct shocks in automotive. You can place this recorder into a car and use it during crash tests, collect the data, collect the information about the shocks. And also you can use this device in transient capture analysis. For example, you have some kind of metal frame, you place our portable recorder, and you make some impacts and analyze the data. Our RL-R17 has two work modes. The first one is called continuous recording. In that mode, device captures all the data, even when there are no shock impacts. It takes a lot of power and decreases maximum lifetime. For example, in that mode and the maximum sample rate, you can write less than 720 hours, but you'll get all the data. It will be uninterrupted, and in that case you'll get a continuous recording. Also, we have a shock event recording. In this mode you set the triggering parameters for the shocks, and in that mode the device will capture only triggered shocks with level above the trigger. And this mode takes less energy because the device will go to the state which we call sleep and only wake up on shocks. And in this mode you can have a rather big work time. We will discuss all these modes today, and also now we have another work mode which extends continuous recording. In this way you can use your device like a 3-axis accelerometer. You connect it with the computer, open our special software, and get real-time data from the device. So here you see that we have a special software which is called LogUP. Here you can connect the device, check its settings, load the data, update the device, read the recordings, create graphs, and so on. Today we have, I will turn on the camera. Here you see we have a shaker, and we have a special fixture for this device. And inside of this fixture we have a regular accelerometer, and all this setup is connected with our RLC21 controller, and we are going to perform shocks. Here you see the profile, and after that we will open the recorded data from RL-R17 in its software and check the results. Here you see the picture of the setup, and now I think we can switch to our software. Let's open if any device is connected. I switched on the device, and here you see that we have an RL-R17, its serial number, and the information. Here you see, I think I have some connection issues with my USB port in the PC. Now let's double check that our device is connected. These recordings happened when I switched the modes, so I think now we can delete the recordings. And now let's go back to our software. And here you see the button which is called Device Settings. We go here. And here we see our current configuration name. You can create your own. Main Settings tab, shock event recording, and additional settings. Our first mode will be continuous recording, and this mode disables shock event recording. Here in the measurement range, you can select the desired amplitude range. We will use the first one. Here you see the sample rate, measuring mode. Also, you can set the desired start time and delay the recording. Also, you can set the read period for our temperature and humidity sensor from 1 minute to 1 hour. And replace axis. That means if you have an accelerometer which is connected with the x-axis, you can switch it to y-axis and continue the recording. After that, we have additional tab. Here we can set the USB connection and auto zeroing our results. So I think we can apply this configuration. You see the message that the settings have been written successfully to our device. Press OK. And after that, I'll open desktop. Here and disable my cable. After that, I'll switch device to the recording mode. And now we're going to create our shock profile, perform some shocks, and analyze the results with our portable data recorder. We go to create test in shock. We will set our amplitude to 2G. Leave these parameters by default. In schedule, let's make 10 shocks, and all of them will be in manual mode. After that, we go to channels. Here we see that we have 10 millivolts per G IP sensor. All other channels are disabled. And here we have our shaker. After that, let's apply the settings. On my amplifier, I set the gain to the 30% level. And now let's start the test. Let's perform a shock. Let's make a pause between them. Now I'll turn off the amplifier, and after that I will switch back to LogUP and connect our device. You see that it's connected, and we go to download the data. And here you see our continuous recording. Let's download it. Here you see the graph, it's RMS from time. Let's close it. And here in the panels, we open data files. Here you see the device, the serial number. Let's expand it. Maximum acceleration, you see it's our 2G, sampling rate, date, duration, and so on. After that, here we can open our acceleration from time graph. And you see our shocks here. Now let's add another graph. It's called real-time temperature. It will be temperature versus time. Here you see that we have about 25 degrees Celsius in our room. And let's check the humidity. It's about 26–27%. After that, here you see that we have a lot of other graphs. We can create shock spectrum, draw humidity in real time mode, draw error mass, displacement, acceleration, maximum values, and all the parameters which were recorded during the test run. Let's order graphs. Here you see, and here in the panels, we have our hardware here. And now we can switch the real-time mode. We press this button. So the device entered the transferring mode. Here you see the real-time temperature is drawing now. Let's open RMS in real time and go back to desktop, start the test. And before we start, let's in schedule disable manual mode. And start the test. And switch back to LogUP. I think we can change the period between the shocks and test it again, but I think it's more interesting to talk about the second mode. Let's stop it. close all the graphs. All the panels. And then we go to device settings and switch to shock recording. Here we see that shock event recording mode is enabled, and here we have 3 additional modes. In this mode, same for all axes, we set parameters for all 3 axes of our accelerometer. It's shock start level, shock end level, indent, hold interval for the shock, and max capture time. Also, we have individual settings for each axis, and by full acceleration, in this mode, we will set the shock start level at 1G and end level at also 1G. Let's apply the settings. Close all the panels here. And now I will disconnect the device and switch it to recording mode. We go back to our desktop, switch back to manual mode. And start the test. Every time the shock is performed, the device blinks red, and you see that the shock is captured. If we fix our camera, maybe I'll make an additional tutorial about this device and you'll see it. Let's wait some time to keep pause between the shocks. Let's change the level. All our shocks are done. Now let's stop the recording process. And switch to LogUP. Let's download the data. Here you see that our shock recording is done. Let's download it. Here you see our acceleration from time graph. It shows one single shock. And here in the panels, you open file content and see all the captured shocks. You see the shock duration, full acceleration peak, and maximum acceleration on the axis here. And if you click here, you'll open a graph with this shock. On the graph, we have all 3 axes, triggering level here. Let's switch. So in this mode, you can capture only shocks. So we don't get any other useless data. Also, here in the panels, you have calculating values. you can calculate error mass on your data recording. For example, we have a continuous recording. You can select it, choose a channel, and calculate error mass on the desired time period. I think that in the future versions we'll get more features for this tool. And now let's check the questions.
Yes, actually, we have a number of questions. So the first question is, are you planning to release a version with the GPS, or is there GPS already included?
We talked about this feature, I think, a year ago when we had a webinar with this device. And I can say that maybe one day this data recorder will have a GPS option. I think I know that there were some prototypes, but it's being under development now, and some tests. But I think in the nearest future we will get this feature.
Okay, we hope to see it at our next release. The next question is, what is the downloading speed of files?
So here, when we press download data, we have a parameter which is called approximate download file, which is calculated according to the file size. For example, if you have 2 days of recording in shock mode, you'll see here the values, for example, how much it will take to download the data from the device, because sometimes it may take a lot of time, because we can have a huge recording with a big sampling rate. And it is worth mentioning that we have a USB 2.0 on this device, but it has also IP65 protection. So to find out how long it will take to download the data, here you have an approximate download time.
Okay, I think everything is clear, and there is one more question. Can it work with regular batteries?
Yes, this device has a changeable power supply. Now we have special batteries, but you can place regular batteries and work with them. But in that case, you'll have less lifetime of the device. So I recommend to use special batteries.
Okay, for now, that's all.
So let's go back to our presentation. And I think now we're coming to an end of our webinar. So we discussed our technical specifications of RL-R17 data recorder. I showed you the application ways, and I showed you all the work modes. And I think we will make another video about this, and I hope you are interested in it. And I'm really sorry for these cable issues. I will double check it next time.
Yeah, sorry for this inconvenience. To conclude, I would like to say that RL-R17 is a great choice for a large variety of vibration monitoring tasks such as shipping, storage, machine diagnostics, roller coaster safety, and others. If I could describe it with 3 words, I would say portable, powerful, and protected. Thank you for taking your time and watching this webinar today. If you have any questions, please send them to our email address.